All right, so this is for our Monday class. This is Math 1301, and today we're going to talk about basic geometric shapes, their perimeter, and their area. Perimeter is a measure of length, and area, obviously, is a two-dimensional area. If we had something, for instance, if this were 8 centimeters, if this square, so this is a square, and the square is defined by these are all right angles and the sides are all the same length. If this was 8 centimeters, length would equal 4 times that. 4 times 8 are 32 centimeters. And area will be measured by 8 squared or 64, but notice that it's centimeters squared. So we should notice that when we have the measurement, like centimeters or meters, that the perimeter is measured in centimeters and the area in centimeters squared or meters or whatever the measuring standard is. So if it's inches or feet or whatever it might be, that length for a square is 4 times the sides. So if we're going to do perimeter, this is here to here, here to here, here to here, and so forth. And to add those up, we could do S plus S plus S plus S, or 4S. And so for length, we get 4 times S, or 4 times 8, 32 centimeters. For area, it'd be that side squared. Or sometimes we say the base times the height in these objects. And that would give us base is 8, and the height is also 8 centimeters. And so we would get that. Now, if we had a rectangle, where again we have right angles here, but now we have the length and the width, these aren't the same. So let's suppose in this case our length was 10 and our width was 5. In this case, we would have the perimeter, this perimeter, the length around the object. This perimeter would equal to, it's written form in terms of formula, 2W plus 2L plus 2W. In this case, we'd get 2 times 10 plus 2 times 5, so 20 plus 10, this is 30. And again, depending on our measurement, let's suppose this is feet, we'd have 30 feet. But for the area, we would instead have L length times width, which in this case is 10 times 5, or 50. But since it's area, it's 50 feet squared. 50 feet squared. And so for a simple square, the sides are all the same, and right angles at each of these, we would get the perimeter, the length around it is 8 plus 8 plus 8 plus 8, or 4 times 8, 32. And the area would be this base times this height. In this case, they're the same. So it's 8 times 8, or 8 squared, 64. When you move to the rectangle, it changes a bit because the length and the width, these are not the same like they are in the square. And so we have 2 for the perimeter, the length around this thing. We have 2 of these sides, so 2L, and we have 2 of these sides for width, 2W, so 2L, this plus this, because this is 10 feet, and this is 5 feet. And then 2W, this is 5 and 5, 10 and 10. Add all those together, you get 30. And then the area, again, is this base times height. And so that's the basic of square and rectangles, the most common or most basic of objects. All right, now if we move our attention then from squares and rectangles to another very common object, that is the triangle. And we're also dependent in the discussion of the triangle. So let's start out with a right triangle. And that's where we did this with similar objects, where in the triangle, the perimeter is just going to be the sum of these sides. Now, often in triangles, right triangles at least, we label these A, B, and C because of the Pythagorean theorem of A squared plus B squared equals C squared. And that does play a role in this perimeter discussion because sometimes we need to find one of those sides, and this particular formula gives us the key to finding a missing side, which is not uncommon in the world of geometry. The perimeter here is just A plus B plus C. That's the length around the triangle. And so if you were a walker and you were out walking or jogging, and you wanted to determine your distance, if your path took you along this triangle, you start at your home, you run down one street, you cross across some field, and then come down another street, you'd say, well, how far did you run? If these were miles, and you say, well, this one is 4 miles, and then you said this one is 5 miles, and then this one here would have to be 3 miles, then the perimeter, or the distance the person ran, would be 4 plus 5 is 9, plus 3, 12 miles. That would be quite the jog. So perimeter on that is fairly simple. Usually what happens with triangles is that it's not as simple as just add these 3 sides together. Usually there's some aspect of, I need to find a missing side. So just be aware, we're going to come back to this Pythagorean theorem here in just a minute and show how to use the Pythagorean theorem to find missing sides. But for this problem, we'll assume we know it. 4 miles, 5 miles, back at 3. This is home. We start here, run this way, this way, this way, add it all up. Our Fitbit or our cell phone or whatever it is tells us we went 12 miles. Now the area of that for a triangle is 1/2 base times height. So that means the hypotenuse does not factor into this area discussion. In this case, in a right triangle, we're going to use this base and this height. I'll show you an example where it doesn't work out quite that simple, and we're going to calculate 1/2 times 4 times 3. So we're going to get 12, 4 times 3 is 12, divided by 2, 6 miles. Only in this case, it's area, so it's squared. 6 miles squared. And so this area in here is, you can see why it's 1/2. You see, like if we had a rectangle, you can see if we had a rectangle, it would be 4 times 5, 20, but we're cutting this rectangle in half. And so you can see why it's 1/2 times base times height, or sorry, it'd be 4 times 3. Sorry, 4 times 3 would be 12. 12 would be the area of this rectangle. And we're cutting that in half. So instead of 4 times 3, it's 4 times 3, and we cut it in half. So 1/2 base times height. So it's really just the rectangle cut in half. And so that's why it's base times height times 1/2, because we're taking half of it. And so this is how we determine the area of a triangle. Now, here's where we get into a situation where additional information is really helpful. For instance, if we have a triangle like this, and we are told that this one is 5 feet, and this one is 12 feet, and we want to know the perimeter of this triangle, we now have a missing piece of information. And so the normal A, B, C, plays a role here in using the Pythagorean theorem, plays a role here in determining this missing side. So here we have A, which is 5 squared, plus B, which is 12 squared, equals C squared. Notice it equals C squared, not C. So 5 squared is 25. 12 squared is 144, equals C squared. And this is 169 equals c squared. Now the normal way of solving this in an algebraic way would be to take the square root of both sides. And in algebra, you know that the answer would have to be plus or minus the root. But in the case of geometry, we don't have negative sides. We tend to deal in only positive numbers. Like this can't be a negative length. You could be measuring this somehow, like the difference between going down versus up or left versus right. But in a general context of I just need to find the length of the side, I'm going to ignore the negative of this. And so the square root of both sides gives me plus or minus 13, but I'm only going to use the positive. So this c is 13 feet. So now if I want to determine perimeter, notice I could have determined the area without finding the hypotenuse. I could have done base times height, 60, and that's half, so 60, 30 feet. So the area of this triangle, area, would equal 1/2 times 12 times 5, or that's 60, a half, that's 30 feet squared. And for the perimeter, I'm going to add these up. So 5 plus 12, 17, 30. Oh, that's ironic. So the perimeter is equal to 12 plus 5 is 17 plus 13 is 30. Only instead of feet squared, it's just feet. So it's just coincidental. Those are equal to each other. But here we have a situation where using the Pythagorean theorem, we found the missing side. We then use that information in order to solve for the perimeter. And so there's a basics on finding the area and perimeter of a triangle. Now, we can do something a little more complicated here, and that is a triangle that is not a right triangle, and it forces us to have to do some calculations. So let me give you an example. Let's suppose we have the following triangle, and we have we'll assume it's an isosceles triangle, meaning that didn't work out very well, but that these two sides are the same length. And we find out that these two sides are the same length and that they're both length 15 feet. And that this here then becomes the height of this triangle. There's our height. So in the formula, 1/2 base times height, we need to find, these 15s don't help us other than finding the perimeter. But on the area, you can see here that we need this base across here. All right, now, if I were to tell you that the height of this object here is 9, if I told you that was 9, what we have then is two right triangles. We have one like this that is 15 feet, 9 feet, and we're missing this side here, A. And we also have another triangle here, you can see it, where this is 9 feet. This is 15 feet, and again, we're missing this. It'll be the same A, because as you can see, these are the same triangles flipped. So we have two identical triangles here. So we could do one of two things. We can find the area of one and multiply by 2, or we can find the height, multiply this entire base times that height, which is what I'm going to do. But let's see. Let's solve for A here. So we have A squared plus B squared equals C squared. A squared is what we're looking for. B squared is 9 squared, and C squared is 15 squared. So we're going to get A squared plus 81 equals the square of 15. What is that? 150 plus 75, 225. So 225 minus 81. So it gives me 8 from 22. So this looks like a squared. So I'm going to subtract 81 from both sides. This will give me a squared is equal to 144. So we can see from this, we take the square root of both sides, that a is equal to 12 feet. So this a is 12 feet. That means this a is also 12 feet, which means the base across here, if that's 12 and that's 12, the total base across here then is 24 feet. So now we get to this area, where area is 1/2 base times height. We have 1/2 times 24, and be careful, the height is this, not the hypotenuse of these two right triangles here, not that side, but it's the height of 9. So 12 times 9, this is 108 feet squared is the area. And then for the perimeter, we're just going to add all those, 15 plus 15 plus 24. So 30, 40, 54. 54 feet is the perimeter. There's the area. So if you have a triangle like this, and you're given a couple of pieces of information, what we want to do is calculate whatever missing piece it is, either this height or this hypotenuse or this base, and solve. And then from that, find the area and find the perimeter. And so this is how, this problem here, you would need this, these were the missing objects here. You know, we needed these two numbers so we could find this total. The missing items here, we needed it for both the area and for calculating the perimeter. So 24 plus 15 plus 15 gives us the perimeter. And then the area is this height. These two sides have no impact on the calculation of the area. We could do it if we didn't have those and just had this and this, we could calculate the area. And this is 24 is the base here. And we have a height of 9, so we do 1/2 base times height. And that gives us 108 feet squared, because it's area, and 54 feet is the length around that triangle. So that's how we handle a triangle. And that leaves us with one more object that I'd like to cover today. And that is the circle. And you're familiar with the calculation of the circle. There's a formula that you've heard your whole life. So we have a circle, and here in the circle we have a radius, r. So if our radius, in this case, if the radius, for instance, if our radius is equal to 5 centimeters, our area formula for a circle is pi r squared, or pi, you can even leave it as pi. If you need to calculate the number, 3.14 is fine, close enough. You don't have to get out beyond that. And then the perimeter, which also is called circumference in the case of the circle. So this journey along the outside is 2 pi r. So if we have this 5 centimeters, we'd say pi 5 squared, or 25 pi. So about 78 or something like that. But you can even leave it like that. I'm fine with that. With centimeters. And then this one, centimeters squared. And with this one, we'd have 2 times pi times 5. So this is 10 pi centimeters. Or if you wanted to, you could write this out as 31.4 centimeters. That will give us the perimeter of this circle, and or circumference, the normal term for that. And then the area of the circle, pi r squared, is 25 pi centimeters squared. You could write this out. I think it's about 78 centimeters squared. You can leave it the pi. That's fine. These answers are fine. You don't necessarily have to multiply it out with your calculator. All right, now, one thing that we can do with all of this is we can take these things and combine them, where we take a circle and we inscribe it inside a square, like so. And now, if all we're given is one piece of information, we should be able to find what is the area of these somewhat triangle-shaped corners. They're not exactly triangles. But they are shaped a bit like a triangle. Two of the sides look like triangles. One is curved because of the circle. So if we want to find those three blue areas, and the only information I were to give you were the length of the side of the square. If I told you this square has a side of 8, say 8 meters. Suppose this is maybe a giant swimming pool or something, I don't know. Water treatment center, whatever it is. So we have 8 meters. If I said the length of this side is 8 meters, and I asked you what is this blue area, the area of the blue area, well, we'd say, well, I'm going to take the area of the square and I'm going to subtract the area of the circle from that. So I'm going to find the area of the square, and then I'm going to subtract out the area of the circle so I can find the area of those 4 blue areas, those 4 blue sections. Well, the area of the square is 8 meters squared. And the area of the circle now, we don't have R, we don't have the radius, but the radius is half the distance it's from the middle of the circle to the side, so half the distance of this entire thing, right? This whole thing. And if it's a square, 8 meters here, 8 meters there, that means it's also 8 meters there. If that's the case, that's known as the diameter of the circle all the way across. The radius is half that. So if the diameter is 8 meters, this means the radius then has to equal 8 meters divided by 2, or 4 meters. So the radius is from there to there. The diameter is 8 all the way across. The radius is 4 from there to there. So here we have pi 4 squared. 4 meters squared. This gives us 64 meters squared minus 4 squared, 16 pi meters squared. And so the area, this one you may want to multiply out, because 64 minus 16 pi won't give you a number. You're going to have to calculate. So 3 times 16, 48 is about 50. It looks like it's about 14 meters squared, something in that range. And so you should probably punch it in your calculator, 3.14. So you get around 50. 64 minus 50, about 14 meters squared. And so that's how you could take a circle, inscribe it inside a square, and then calculate using both your knowledge of the area of the square, area of a circle, and calculate it that way. All right, so on Wednesday, we'll cover a couple other little problems with this and then spend the rest of our time talking about volume and the volume of objects like cubes or spheres or cones. Those would be the 3 main ones we talk about, or cylinders, those 4. We'll cover those 4 3-dimensional objects. We've done 2-dimensional, we've done square, rectangle, triangle, and circle, those 4. And now we're going to take those 4 and the information we learned from it actually a little bit and apply it now over in 3-dimensional settings of cylinders and cubes and so forth. All right, that's our lecture.